we have done this one, we've done this one, we've done this one, we've done this one, we've done this one. Now we're getting to a little bit more complicated one. So now we have 8.75 pounds per cubic foot. Okay, so this is, and we want to convert to grams per milliliter. So you notice what these units are. Pounds and grams are a unit of mass, and cubic feet is a measure of volume. Milliliters are a measure of volume. So this is actually a density measurement. Pounds per cubic feet would be an English system, and grams per milliliter would be the metric system. Got a couple of conversion factors here. We have pounds to kilograms, and we also have inches to centimeters like we had before. So I'm going to move this whole thing up, give us a little more room to work this problem. And I want us to think about our conceptual plan. So we're going to write down what we have first, pound per cubic foot. That's what we have, and this is what we're trying to get to. We're trying to get to grams per milliliter. All right, now, here's the thing which I think students kind of mess up or don't realize. I can do a set of conversions to convert the numerator, and I can do another set of conversions to convert the denominator. So I'm going to go take these one at a time. What do I need to get from pounds to grams? And I look at this information that I have. I say, well, I have pounds to kilograms. So if I go pounds to kilograms, I should be able to then go from kilograms to grams. So that should be a 3-step process. And cubic feet to milliliters, that one's a little more, got to think about that one a little bit more. Cubic feet, well, let's get it into the metric system. So cubic feet into cubic meters, that would help. And cubic meters into cubic centimeters, and then centimeters cubed to milliliters would help. Now your next step might be, let's see, how do I go from cubic feet to meters? Well, I don't even have that information. I have inches to centimeters, so I actually need to do another step. So I'm going to erase this little line right here, and I'm going to add some steps to this. So I'm going to go cubic feet to cubic inches, cubic inches to cubic centimeters, and actually I don't even need to go to meters now. So because I have cubic centimeters, I can go straight into milliliters, because if you remember that picture in the other video of a liter, that one little guy in the corner, 1 centimeter cubed is equal to 1 milliliter. So if I have it in centimeters cubed, I can get milliliters. So, all right, so let's make this just a little bit cleaner. It's gotten a little bit messy here. Let's erase all this. And let's redraw this. Now that I have my plan, I'm going to go from cubic feet to cubic inches. I'm going to go from cubic inches to cubic centimeters. And I'm going to go from cubic centimeters to milliliters, because I know that those are directly related to each other. All right, so that's my game plan. So what I'm going to do to solve this problem is I'm going to convert the top first, pounds to grams, and then I'm going to convert cubic feet into milliliters. And I can do this in one big long calculation, or you can break it up into separate smaller calculations. I'll do it as one big long one. So I'm going to find my starting number, which is 8.75 pounds per cubic foot. And you notice it doesn't say 1 foot cubed, but that's what that means. So I'm just going to put 1 foot cubed down here, and I'm going to draw out my railroad tracks. And I need pounds on the bottom. And I have a conversion factor, which is 2.205 pounds for every 1 kilogram. And so pounds are going to cancel pounds. And now I'm going to go kilograms on the bottom, grams on top. And I know that there are 1,000 grams in every 1 kilogram, or 10 to the 3 grams. Remember, it always gets applied to the base unit. Grams is the base unit. So that 10 to the 3 gets applied to the base unit. And once again, step by step, I'm going to cross off kilograms. Now, if I was to do this calculation right now, what units would I have? I would have grams per cubic foot, okay, because I've crossed off the pounds units. But that's not what I'm trying to get to. I'm trying to get to grams per milliliter. So now I need to work on the cubic foot unit. And so let's take a look at that. So to work on the cubic foot unit, I'm going to first convert to inches. And so I need feet on the top. Let's change it to be consistent with pen colors. I need feet on the top and inches on the bottom. I know that there are 12 inches in 1 foot, but it's cubic feet, so I need to cube this entire factor. And now cubic feet will cancel cubic feet, and I'm going to have cubic inches on the bottom. Okay, so now I have grams per cubic inch. I need to go to centimeters cubed, so I need 1 inch equals to 2.54 centimeters. And once again, I need to cube this entire factor because this is cubic inches, not inches. So that cubic inches is going to cancel that cubic inches. Now I have it in centimeters cubed. So now I need centimeters cubed on top and milliliters on the bottom. There's 1 centimeter cubed in every 1 milliliter. So now I can cancel this and that cubed up there. And then when you do this calculation, you got to be really careful. You got to remember this is 1 divided by 12 times 1 divided by 12 times 1 divided by 12. This is 1 divided by 2.54 times 1 divided by 2.54 times 1 divided by 2.54. Or obviously you can use a cube button on your calculator. But remember, you're cubing this entire factor. Okay, and when you do this calculation, this turns out to be, I'll write down the top and the bottom. So it's 8750 grams divided by 62438.6 milliliters on the bottom. So what I did was I just calculated everything across the top, which is 8750, so 1,000 times this. And then I took 2.205 times 12 cubed times 2.54 cubed, and I get 62,338.6 milliliters. If you calculate this, and then let's just, while we're doing this, let's just check our sig figs. So there's 3 sig figs right here, 4 sig figs right here, and then infinite sig figs for everything else. So my answer needs to have 3 sig figs. So this is going to equal to 0.140 grams per milliliter. Okay, final answer with 3 significant figures, and I've done this big long conversion here to get to that point. All right, let's take a look at the last problem. As I said, we're getting progressively more complicated. Concentration of carbon monoxide in an urban apartment is 48 micrograms per cubic meter. What mass of carbon monoxide is present in a room measuring 10 feet by 11.5 feet by 20.5 feet? 1 inch equals 2.54 centimeters. And remember, that is also an exact number. So why don't you stop the video, think about this for a few minutes, try setting up the problem. Meanwhile, I will erase the stuff that's on here. Okay, so we want to come up with our conceptual plan looking at this problem. This number right here, 48 micrograms per meter cube, that's actually your conversion factor. And why I say that's your conversion factor, that's like your 12 inches equals a foot. Because what this means is it doesn't matter what size room you have, that is the amount of carbon monoxide that's in that room. So if I have a 5 foot by 5 foot by 5 foot room, it's 48 micrograms per meter cube. If I have a 100 foot by 100 foot by 10 foot room, it's 48 micrograms per meter cube. So that's actually your conversion factor. It's a little bit different from some of these other ones. That's the same thing as the 1 inch equals 2.54 centimeters. I do have that conversion factor also. So when you think about your conceptual plan, you want to think about the size of the room, and I'm trying to go to the mass of carbon monoxide. all right? And by the size of the room, I actually mean the volume of the room. So if I want to go from volume to mass, this is another little bit of a weird unit, but it's micrograms per meter cubed. It's mass per volume. That's actually a density number. So this micrograms per meter cubed is the density of carbon monoxide that's in the room. So to go from volume to mass, what I need in order to do that conversion is I need to have volume on the bottom and mass on the top, and volume can cancel volume, and I'll end up with mass. So this volume and mass term is actually a density term, which is this term right here. Okay, so how do we actually want to do this in terms of units? Then we're going to say something like, we're going to have feet cubed, and we need to get that somehow into meters cubed. And if I have that in meters cubed, then I can multiply that times micrograms per meter cubed. Meter cubed will cancel meter cubed. And then I'm going to need to convert micrograms into grams. That's my general conceptual strategy. So how am I going to go about doing this? Well, the information that I have a distance, length times width times height, or this is probably the height times the length times the width. So these are already in feet. There's two ways you could attack this problem. I'm going to show you what I consider the easier way, which is to convert each of these into meters. Convert the feet to meters, and then multiply them together instead of having to cube it in your factor. So then the strategy for there is, I've got feet, I'm going to go to inches, I'm going to go to centimeters, and then I'm going to go to meters for each dimension. So you're going to do basically 3 of the exact same calculation. So let's set this up how we want to do this. 10 feet. We'll set up the railroad tracks. I need feet on the bottom and I need inches on the top. So I got 12 inches in every 1 foot. Feet cancels feet. Next step, I need to go to centimeters. So I've got 1 inch equals 2.54 centimeters. Inch cancels inch. Next step, centimeters to meters. So remember, we always apply it to the base unit, 10 to the minus 2 meters for every 1 centimeter. Centimeter cancels centimeter. And if we do this calculation for 10 feet, it turns out to be 3.048 meters. All right, I'm going to save us the trouble of watching me do this for all 3. It's the exact same calculation, just different starting numbers. 3.048 meters times 11.5 is 3.505 meters times 20.5, which is 6.248 meters. And if I do all those, multiply those 3 together, length times width times height, we get 66.75 meters cubed. And how many sig figs should this answer actually have? Well, look at these. These all have 4, so maybe it should be 4, except these only have 3. So really this should only have 3 sig figs. So I'm showing you an example of how I usually carry 1 extra digit in the intermediate calculations and then round it at the end. So this really should be rounded right here to 3 sig figs, which is that decimal place, which means that 5 is going to influence and it's going to round it up. So 66.8 meters cubed is the volume of the room. Okay, so in order to find the concentration of carbon monoxide, I'm going to take that volume, 66.8 meters cubed, and I'm going to multiply it times 48 micrograms per 1 meter cubed. Meter cubed cancels meter cubed, but I look back on the problem and it says I want what mass of carbon monoxide is present. This one doesn't actually specify, so that we could just leave it here, but a lot of times the problem will say what mass of carbon monoxide is present in grams. So let's just do this in grams because that's usually what the answer is going to look for. So I'm going to need one more step here. I'm going to need micrograms on the bottom and grams on the top. We always apply it to the base unit, so it's 10 to the minus 6 for micro. So something like that. And that is going to mean, when we do this calculation, that is going to equal to 3.21 times 10 to the minus 3 micrograms. Oops. Grams. But if we look at the sig figs, there's 3 on this one. There's only 2 on this one. So really my answer should only have 2 sig figs. So this should be 3.2 times 10 to the minus 3 grams. Okay, it's been a long video. You've hung with me for 7 different examples. There'll be many, many more for you to practice. But we've taken a look at a bunch of different common mistakes. Let me just sort of reiterate what those are and make sure we understand how to handle them. So the couple of tricky ones, anytime you have a cubing factor, you have to cube everything, or a squaring factor. So anytime you have a density term, it's going to have a cube factor. This is a density term. This one's an area, so areas are also going to be problematic potentially. So you remember you need to square or cube. You need to cube this unit, square that unit. The other thing is you always want to look for a starting unit, which in this case is dollars per gallon. This one's dollars, this one's days. And then you're going to have some conversion factor, and a good plan is to come up with a conceptual plan that helps you figure out how you're going to cross out those units. 1, 2, 3, 4 steps. 1, 2, 3, 4 steps. So I figured out I'm going to go to feet to inches to centimeters to meters. That's a 4-step problem. I've made 4 steps right here. All right, here's a great place to stop. That finishes our main topics in chapter 1. Now we just got to do lots of practice problems.